welcome to Lancaster AI. My name is Rich Everts. I am the co-founder and CEO of Suji. I'm also the founder of Lancaster AI. And you can reach me at the information here. And I always want to note whenever I begin these talks that all these opinions are my own and not representative of my companies, organizations, or any of my clients. So today's going to be a little interesting since I am incredibly sick, actually, and I took a lot of cold medicine, and so I'm kind of flying high here right now. So we're going to see how this goes. So I'm interested to hear as much as you are what comes out of my mouth today. So today we're going to be talking about creating deepfakes, and I know people are interested in this, and there's a lot of reasons why, but in case you don't know what deepfakes are, I'm just going to show one here real quick right out of the gate, and this is actually one of the most popular ones right now that's finding its way around the internet. So if you're a Star Wars fan, okay, you'll like this one. All right, so I'm just going to play this.
All right, guys. Well, is this the background that we're going to use? Is there a way we can do like a green screen? We bring in a green screen or Jimmy? He just follows me around with a green screen.
You ever done a reaction before?
Yeah, I mean, I've reacted.
So I want you to check out the quality of George Lucas, or quote unquote George Lucas, who we know it's not, but check out the quality as we go through.
Oh, God. Oh, there it is. There's my name. Another check for Daddy. Does this end or? Oh, you dropped something. There's Ray. Oh, what character development. What an arc for Ray, huh? Jesus Christ, at the end of Empire, Luke had his hand taken off and Han Solo was in carbonite or whatever. Oh, this is great. It's great because I didn't make it. Ultimately, I'm not to blame. Oh, that's Rose. Her sister died or something, trying to throw a space grenade. And they saved a bunch of horses or something. Oh, look, it's Camino. Look at that. That's where all the cloners live. Oh, I can actually feel my life essence draining from me as I watch this. This thing needs more guns. See all you guys still all pissed off, all worked up. One of Ralph McQuarrie's pieces, just taking a shit on that. Hey kids, you ever see a Star Destroyer come out of the ocean? Well, you're gonna see it now. People give me shit about Jar Jar Binks. I said, oh, this is stupid. Well, you happy I'm gone now? You don't have Daddy to kick around anymore because this is what you get. What is that? There's C-3PO. And there's a hairdryer with a robot. There's just soccer balls, a robot, a hairdryer. Let's put a dildo in there. Why not? Because you know what? We're just on my saga right now. That's what this is. Merry Christmas. You know what that sound is? That's the sound of 1,000 executives just taking a shit on my work. Oh look, it's desert. It's another desert planet. Oh, I wonder which one this is. How exciting. The saga will end. Thank God. Put it out of its misery. Oh, there's the space horses. Ooh, good. Thank God they tied up that gem of a storyline. Oh, I'm so relieved I didn't make this. I'm so relieved. This makes Attack of the Clones look like Citizen Kane. Take a lightsaber to the Saga's head and just cauterize that thing because it's time to put this to bed. You know, I know the ending of this film. I'm going to spoil it for you. Spoiler alert. Here's how the film ends. You ready? At the very end, Star Wars dies.
All right. So I'm not going to let that go on too much longer, but you get the idea, okay? So in that particular instance, we had quote unquote George Lucas giving his parody of watching the Star Wars new trailer that came out. And so the interesting thing about that is you see a lot of these being used now for this specific social use. So initially, why did the deepfakes get started? For porn, right? I mean, that's why all these things get started, because they wanted to put Emma Watson's face on like all these different porn things, right? And poor Emma, right? But so that's essentially why a lot of these deepfakes got started. And then they moved into things like more videos with like Nicolas Cage, like you see Nicolas Cage in all these videos and stuff. And so they started swapping them out there. And then they started showing like a lot of the political ramifications that you would have, right? So then they showed Barack Obama and Donald Trump saying all kinds of random crap that they normally wouldn't say, right? And then trying to fool people with that. And so then what ended up happening with some of these adversarial networks is that there's a lot of other uses for them, okay? But the critiquing is very popular right now. You'll see a lot of these face swaps. You can go on there right now. Just type in deepfakes in YouTube and you see them all. Now, this is the technology behind it is called generative adversarial networks. And these are a new kind of neural network. And I'm going to explain how they differ from traditional neural networks and how they work. And then we're going to walk through and talk about how we actually create one of these face swaps. And then how you could go through and talk more about the generative adversarial network. Now, the GAN, that's what we're going to call it, a GAN, you can also use it, and traditionally what it's used for now is creating data sets of things that didn't exist before, right? So you can actually create pictures of people. They have thousands of high-res pictures of people that never existed, but they look real as anything. And so there's phantom avatars of people. And so there's a lot that you can get out of these generative adversarial networks. I know one of the most recent great use cases was being able to create cancer. Like they created lungs with cancer in them, so they trained the GAN to understand these different types of cancer-free, cancer-ridden lungs, and they actually were able to generate more data to be able to use in these networks. And the reason that's a big deal is because when you deal with medical images, there's generally not a lot of open source image data sets to use. And so you got to create, you got to find a way to create these massive data sets. That's one of the drawbacks of deep learning right now, is these massive data sets that you need. Okay, so let's talk a little bit about how GANs are made. So let's first talk about the general basics. So you have two things in a GAN. You have what we call a generator and a discriminator, okay? And so in the very beginning, the generator generates an image, just basically white noise, just randomized noise, right? It's a random NumPy array or random whatever array that you have of black and white. And then you have a data set up there of the things that you want it to kind of learn on, to whatever that is. So in this one, it's MN instance, the digits, right? And so what we do is we feed into this thing called the discriminator, the actual image, the real images, and then this generated image, right? Which we'll call X star, X prime, whatever you want to call it. We'll call it X star here, right? So we'll feed it in X and X star, and the discriminator will try to figure out which one is the real one. Okay, which one is the real one, right? And then out of that, we get a classification error. So it either got it or it didn't, right? And so the discriminator here, okay, is trying to, what it'll end up doing is it'll end up reducing the loss on the generator, and the generator will increase the loss on, or sorry, it was backwards. So the generator will try to decrease the loss on these. So it's trying to create a better picture as it goes. So it'll try to decrease loss. And then the discriminator is going to try to increase the loss, right? And we understand that when we deal with traditional neural networks, it's a function to reduce the loss minimization, right? That's what we're trying to do, a functional loss minimization. And so that's what this iteratively train is. And so one's trying to maximize, one's trying to minimize, right? And then we just go through this whole part. So this guy's trying to fool this guy, going back and forth, right? So, what ends up happening is that we have, if you understand what encoders are, right? So we have an autoencoder and an autodecoder. So an autoencoder is really trying to take some kind of data and convert it into some kind of dimensional space here, right? Some kind of other information. It's trying to encode it into something. And a decoder is trying to take that information and put it out into something that can be understood. And in between those two is this thing called a latent space, right? A latent space. And so what you have is, in between these two resides this latent space of information. And that is the information that it uses, sort of like when a brain develops, it kind of like has this idea, map, of where things go. And you can input anything in here, and it maybe uses this little part of the latent space and this little part. And when you combine those, when you go in to actually decode that information through here, it'll give you this image out here, right?
Would the latent space be like a palette?
It's not, no, it's actually a mathematical structure, right? Yeah, so it's not just random noise and stuff that you would have like in a palette. Like a pallet's usually a sequential list of data.
Oh, well, I was thinking of a painter. They've got a palette. They've got a separate
Oh,
the
yeah,
colors
yeah.
they use, but they can use those and mix, and they can bring those in. I'm sorry.
Yeah, yeah, absolutely. So if you think of it like, yeah, so that oh gosh, what's his name? Bob Ross, right? So he has his little brushes and he's got his little paint thing there, you know, his happy little trees. And so he has all his little colors around the edge, right? And so he understands where those different objects are lying and how they work together. So yeah, this is Bob Ross's latent space, all right? So at the beginning, this is just a random sample, but over time it becomes much more coherent, okay? So, and the rest of this stuff here, if you're familiar with neural networks, is the same kind of dimensionality, you know, reduction and increase. So we call it upsampling and downsampling, right? So you go from, if you're familiar with CNNs and kernels and things like that, you know, this is a, let's see if we're going down. So if you ever, have you ever seen the neural networks, the maps like in the white papers, where they show you like a 20 by 20 gets reduced to a 10 by 10, and then as you get smaller in size, the feature set grows. Anyway, these are traditional CNNs, okay? Traditional neural network CNNs. They just have this latent space in between them, and it matters for this particular reason. So this right here is called the Nash equilibrium. Now, I'm not sure how familiar you are with Nash, but they had that movie Beautiful Mind, which was about his life. And so the idea is that one player in this game is trying to minimize the loss. So you're probably used to seeing this in traditional neural networks, right? This is the functional loss, a Bayesian sampling here. So it's over a specific range. It always adds up from 0 to 1. And you're trying to reduce it down to 0. And here you're trying to maximize the loss, right? And when you combine these two spaces, this is what a Nash equilibrium is. At a Nash equilibrium, there's two players that are together. And when you reach that equilibrium, when neither player can make a move that helps themselves more, right? So when they reach that point, that's when the equilibrium is reached. And essentially, sorry, that made no sense. But when they reach this equilibrium, ideally your model is trained, because it can't make any more moves. Like it can't discriminate against the computer anymore, and it can't generate any new ones. Like they can't convince each other any more of their truth. Okay? That's what this Nash equilibrium is. And this is what you're actually fighting for. You never reach the Nash equilibrium, though, really. And that's why these GANs are very hard to train. Okay? So it's very, very difficult to actually reach this point. Okay. Now, real quick, just these images that I got were borrowed from GANs in Action. It's from Manning Publications. If you're into GANs, I would highly recommend reading this book. I went through it. It is awesome. It'll show you how to train these GANs from scratch using Python. So if you're into Python, it's really easy. GANs in Action, it's dirt cheap. Manning Publications, they have sales all the time. I think they're having one right now. So you can get it $20, I think, to learn about GANs, something like that. It's definitely worth it. I don't get paid anything, by the way, so I just love their books. They always have amazing books. So what I want to do here is I want to show you what we're going to do. So I'm going to take you through how to actually do a deepfake. All right, and so this is mine where I'm putting Commander Riker from Star Trek. I don't know if you watch Star Trek, but if you haven't, you should. But I'm putting Commander Riker's face on my face for a particular deepfake. Okay? And so what we'll do is I'll show you how to use Face Swap, which is the current really, really good GitHub. It's free, open source that you can use to get this set up. And then we'll walk through all the steps. All right. So the first step that you have to do for face swap is you
I
have,
have a quick question.
yeah,
Decades ago, when people used to manipulate images, let's just say it's not a movie. Let's just say it's a pic.
yeah, for
They
Photoshop.
they used to leave digital signatures. So somebody forensic could go in and see, well, okay, we can see that this is manipulated. And here's the reason why. Using this technology, does that go away?
Yeah, so in terms of so the question is essentially, we used to be able to detect when a forgery would happen a lot more easily, or we would be able to detect it. Will that go away? And the answer is no. You'll see from these deepfakes, they're still not to the point where it would fool somebody like 100% of the time. When you actually look at how these GANs are trained, one of the things that they're susceptible to is blurring. And that's the reason. There's a number of reasons for that, but you can tell in a GAN, especially with the skin, that it's not quite 100% there yet. Okay, but it's pretty close, right? So you can still tell kind of what a deep fake is and what's not. Long term, maybe over the next couple of years, if you think about how far we've come over the last even 2 years with GANs, yeah, we're probably going to have to come up with some kind of system. It's going to have to train to figure out what's a deep fake versus what's not. And there'll probably be some telltale signs. We just don't know what those are yet. So, yeah.
Is that mostly going to be processor speed?
For GANs,
That it's going to allow to shrink the digital signature that's going to be recognized?
no, it's not a matter of processing speed. It's a matter of the algorithms. So it's going to matter of how do we train it properly. Like this blurring situation is, because of just the way that you're going to see how we block out the faces. What'll end up happening is that when we train the system, the around the edges will tend to get blurry. And so that actually gets tied into the rest of the system. So if we could figure out a way to fix that, that might help with that issue. So it's not CPU speed, it's going to be, how do we actually go about calculating these latent spaces and how do we generate them? And yeah, it could be very interesting to see some of the new ones. They just came out with a new one, a new style of GAN called Villain, which was maybe like in the last year, which is very good. But there's still some issues with it, and I'm sure there'll be, within the next year, another really good one, and maybe it'll solve that. So, all right. So let's take a look. So you got to download the repo, right? And it's pretty straightforward. You just go to FaceSwap GitHub and you can download the repo. It's available on Macintosh, Linux, and Mac OS. I prefer Linux, of course. Highly recommend. You're going to need an NVIDIA card to train this. So, but let's take a look. So after you download this and go through all the setup, all your requirements and all those things, you'll need to set up TensorFlow and all that stuff. They have all the instructions online. Then we're going to load up our FaceSwap GUI. All right. I have mine set up with a NVIDIA card because I have an NVIDIA on this. Okay. Now let's take a look at. All right. So this is their GUI, tkinter. So this is a Python GUI, and so it's very basic, but it'll get the job done. Right. That's what we want. So there's basically 3 steps that you have to handle when you're creating a face swap. So you have to set up your input directory, your extract. So you're going to extract the faces from the image or the video sources, right? So you got to pull out the faces first. Then we're going to train them by comparing the faces, and then you got to convert those faces back to your original target image or video. So let's actually do that. All right. So the first thing that we want to do here is input directory, and if you hover over, it'll tell you. So this is a directory containing the image file you wish to process or path it to a video file. Okay. So I'm going to put live demos. Let's see how this actually goes. Alrighty. Gotta remember where to put all these. Okay, so this is my Riker impersonation, my raw video. All right, the output directory where I want to extract them to. Everybody gets to see all my hidden files. Ooh, how exciting. All right, links through AI. Let's do extracts, and then I'm just gonna say extracted impersonation. Okay, and then any alignments. Okay, so let's just take a look at these things real quick. So when you're doing the extractions are not they're not super difficult for the system, so you don't have to worry about batch sizes or really a lot of stuff there. Your GPU, you're going to want to have a decent GPU, and by that I mean you're going to want at least a 1070 or higher, NVIDIA 1070 or higher to do these. You can use the CPU, but it's going to take a lot longer. So I'm going to show you how to do this real quick. I use the default settings just to extract them, and it was pretty good. So I just hit the extract button, and I'll stop it. But you saw the images of the faces that were popped up there, right? And so what I'm going to do here is I'm actually going to show you the finished setup here. It's taking a second to bring it up.
I'd like to see what the initial input looked like.
You want to see the initial video first? Okay, sure, no problem. All right, so let me show you the extracted impersonation first.
Does this only work on video for now, or is it like?
Now, you can do it with static images. I'm choosing to use video. So when you do the training, though, you're still going to want a ton of images, and I'm going to explain why that is and everything. So these are from the extracted video. So as you can see how it tightly crops the face here? It's specifically looking for facial features. And what I've done is, if there's any that are missing, or they're messed up or whatever, so you'll see like maybe they're rotated to the left, or maybe the computer gets it wrong and it's upside down, the face, or it's really zoomed out or whatever, I delete those, right? Because your data sets are important to keep as pure as possible. Because that's what you're going to
They
train
get
on.
deleted automatically?
No, you got to manually go in after you extract them, and you got to go through and look at all your faces and do this. So now another thing, ideally, you would not rely just on one video for your faces and training. So what you want to do is you want to use as many different kinds of photos as possible. So you wouldn't just extract one video for a face. So you're going to see from Riker, I used a couple of different videos because they have to have different lighting, different setups, different angles. Preferably you would have a ton of different pictures, which is why celebrities are so easy to use deepfakes for, is because there's thousands of pictures of, and they're all different, right? They're all different, and that's how this works better. Okay, so you want to see. Let's see here. The original video. Let me see. Let's see. I was doing Blender on that one. Okay. So FF play. Try to think of where these videos are going to be.
No, I wouldn't forget this question. That's all.
Lancaster AI. Nope. Yeah, there it is. Hello, my name is Commander William T. Riker, Captain. William T. Riker of the USS Titan now, and I'm here to tell you I've never met an alien who I haven't wanted to go to bed with. Even with my awesome Betazoid sugar mama, Deanna Troy on ship, I just can't get enough. Wait, what? Shut up when it's late! Okay, so if you know anything about Commander Riker, that was my best impersonation for a little bit there. Alright,
So can I see the files that you're using to swap yours out? Or is that, I'm not asking a good question.
say what?
Well, you have a bunch of images of Riker then, right?
Yeah, so I'm gonna go through them here.
Okay, sorry.
Yep. Alright, so we saw those, and then let's take a look at the actual files. Okay, and so what we do is we go through, and then we do the same thing for the Rikers. Now, what I did was, when I went through Riker, okay, I have, let me show you the videos that we have here. So I have a number of Riker videos.
Recollecting the arrival of a new first officer on board the
So see how far away he is,
and a manual
and notice
document
the darkness of that particular image.
Oh, I may have been someone. Well, you have 12 up there. Raise up.
Now, here's one where it's a nice one, where it's a nice close-up, right? And it has different angles. Good, different one.
Did you have to slice out just the portion where he is so the system get confused with other faces?
Yeah, so what I ended up doing is I fed this to the, I actually have my own custom software that I have that I wrote for this, which will basically cut it up and I can go through and chop it up pretty quickly. But the system, the face swap system, has that. So if you just feed it the video like we just did, and you'll have to go through manually afterwards and delete all the pictures of everybody else that are in there, right?
Still manual effort then.
It's a manual effort,
Okay,
yeah.
thank you.
So one of the things I also did here is I knew that because I know a little bit about Star Trek, I knew there was an episode where Riker actually played two characters of himself in the same episode. He played like a clone of himself. So those were great because he had like different shots, different lighting and everything, got all those. So I was able to get about 5,000 images from that, which is pretty solid in terms of number, but they weren't very varied. So there's only 5 different videos that I used. Ideally, you would have way more variance in your images. Okay. So,
Well, for reference, Riker did some other kind of show. He
yeah.
outside Star Trek. So that would be an example of other places you should go. That's my question.
Exactly. But the thing is that you have to make sure it's the same. The reason I chose Riker is because of his beard, right? And so, because of my beard, I figured it would be a good face swap. Like I probably could not do Jennifer Lawrence very well, right? Or whoever. But okay. So that's where I go through and I do the extraction. Great, awesome. Then, once I have the extraction, then I can get into the training. Dun, 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 dun. Okay, so here's what I do. For this one, you can hover over, it'll tell you. Directory containing training images for face A. This is the original face, the one you want to remove. So this one is me. And what I'll do is finished rich. Let's call it that. And then we'll do the finished Rikers. Great. Now, because I
For my
know
clarity, you're pointing to directories that have multiples of those, correct?
multiple.
Of extracted you and extracted Riker.
Yes. So when you look at there, you'll see that the extracted me probably has a couple of hundred images, or almost 1,000 images. The Riker has about 5,000. Okay. So then when we get into the batch size, so this is where if you're training, you'll need to know a little bit about your system and what you can do. So I reduced the batch size pretty drastically for me, okay? So I have a 2080 in here, in this laptop. It's a desktop class laptop, but even still, it only has 8 gigabytes. So if I had like a 11 gigabyte card or I had multiple GPUs, I could probably keep this at around 64, but I gotta lower it to 32, the batch size. The batch size is how many images you feed in at one time to the system that it'll load in and try to run all the regressions on. And then this was fine. I saved it every 100. And then I do have preview scale. which is fine. There are other settings that you can look up here. So if I wanted to look at the training plugins, and it can tell me, different things, what kind of maths I want, what kind of learning rates, et cetera, optimizers. I didn't worry about this stuff too much because there was no need. Like, your defaults will get you pretty far. But if you're having any kind of problems, you can come in here and take a look at some of the settings. And so I'm just going to train this real quick, and I'll talk a little bit. Oh, right, I forgot where we're going to save the model.
We're a long way from the first instance of Coral Draw, aren't we?
Yeah, here we go. So I didn't spread it out far enough, so there we go. Low res. Okay, so this is the model directory. I gotta say, where am I gonna save the models? It'll save them every 100 or so. And then the trainer. So this is important. So you gotta pick out what kind of trainer you want. I use the original one just because it's easier. But Villain generally gives you better, but you need to have at least 11 gigabyte card in there. So you're probably not going to train this on your home computer unless you have a 1080 Ti with 11 gigabytes, or you're using multiple GPUs. But you can play around with these, and if you're running into any problems not being able to fit it, you can use some of these like allow growth and stuff like that on there. So let's see. Finish rich contains no images. Oh shoot. Crap. All right. Well, I guess I never actually got the images in there. Extracted impersonation. Let's see what's in here. Let's see if that'll work. Finish Riker. I didn't get those in there either. I downloaded them, but I didn't actually dump them in there. Okay. Well, let's just see what we get in here. And I'm not going to show you the whole thing. I just want to be able to show you kind of what happens. There we go. Okay. So here's some of the images. And so what's going to happen, see, this is the discriminator. Remember when it happened, it has generated the white noise, right, at the very beginning of the generator. The generator started with white noise. So this is what it's going through, and it's trying to pick out which one's the real and which one's the fake face. Well, this is obvious, like, with the white noise and stuff. But as you let this train, it'll get better and better, and it'll put all these images in and try to figure out what's what, right? And so over time, what you'll see is my face will be replaced with Riker's over time, and it'll get better and better. And you'll see here, this isn't the best example because I don't have all the images set up in here, but it'll go through and it'll tell you what the loss is. It calculates as it goes through, and it'll come down, 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 down until it tries to reach that Nash equilibrium. But these pictures will get better and better and better. And so that's what it's trying to do, and it shows you that process as it goes through. Now, you may ask, how long does it take to train, right? Because that's an appropriate question. So here's what I found. On a 1070, which is what I used on my desktop machine, an NVIDIA 1070, it took me 100 hours to train this system. So 100 hours to train 1,000,000 iterations. So whatever that works out to, I think it's like 10,000 per hour or something like that. You can hear the fans coming on in this thing. It's very computationally expensive to do this. So I had to start this last week in order to train it to get this process going. And so it will take a long, long time. Plan on it. My video that you have is 30 seconds. Imagine if you had like a minute or something like that. It's going to be computationally expensive. You got to plan on that. Okay. So that's what happens. So basically, you start this training, and then you let your computer run for anywhere from 3 to 7 days, and go do something else, and pray that it doesn't run out of something or another. Yeah.
Just to help me a little bit, what I'm seeing up there, are there correlations between some images of you and some images of Riker, or is this just a random list of stuff that's in that directory?
So what it's doing is it's pulling. It's pulling from input A and pulling from input B.
Right.
Right. And so these here are the generated images.
I understand.
Yep. And so it's pulling just a a list. It'll go through.
So if I look at the second row from the bottom,
Yep,
okay, if I check your second image that's clear,
yep,
and then go over to Riker's first image,
yep.
I see that both of you are facing off center. So that's why I was seeing some patterns there. Is that just coincidental?
That's just coincidental.
Okay, thank you.
Yep, just coincidental. What'll end up happening is that you'll see, by the time you get to your second or third day of training, if you will, you'll see the faces will start to look, this will all be faces. And some of them will look good, some of them won't. And then I'll try to figure out what's what, who's who.
So that area that you said has to do with the static, that represents something that it can't correlate with another image?
This right here?
Yes.
So that's its first attempt. Remember, it starts off with white noise.
Right.
Right. So that's all that is its first attempt on there.
So I'm trying to walk down a path here.
Yep.
So what it's showing is what it found in the white noise that represents something that's in another image that's comparing.
Now, so what it's done is the generator has generated these fake images to try to fool the discriminator and say, hey, these 4 images are images of Rich. And it clearly says, that's ridiculous. These 2 are obviously white noise.
Okay, so those 2 that you got there's part of the image that's clear, it's not covered up completely.
Yeah.
So I was trying to ask, in that section, is it finding something that's a match, or is it saying none of matches?
No, I was just saying, it's a simple classification problem, so either yes or no.
Okay.
Yep, to the whole image.
So the idea that the visual that image I'm seeing part of is irrelevant, it just
Yeah, exactly.
covering the whole thing up.
Exactly, it's irrelevant.
Thank you.
Yep. All right, so that's what'll happen, and that'll go on for many, many days, as I mentioned. All right, so we're going to terminate that. Okay, and then here I'll give you your loss, average since last save, etc., etc. So loss here is 13720. It got down on mine to about 0.02. So it went from 0.13 to 0.02, and then some change. So the losses definitely got reduced. Okay, so then what you do is you go into the convert tool, and then you add in your file. So it'll tell you input directory. So this is containing the image files or video that you wish to process. So for this, I'm going to put in, this is my Riker impersonation, right? My impersonation video. And then I'm going to say, where do I want to save it? It really doesn't matter. We're not going to run this one. And then a reference video if I only used images. So again, if you're not using video and you just want to do this on an image, you got to have a reference video of some kind if you want to create another video. All right. Where your saved models are, right? So this would be our models, where those models are. And then, these are your other settings here. You do have some important settings on this one, all right? So if you go under convert, yeah, it's convert. There we go. So writer, okay. So you got to kind of look at these settings. So it's important to know what kind of container you want to go to. So what kind of video. So this is where you choose things like, is it an MP4? Is it a AVI, MPEG, whatever, right? So and then what kind of codec. So if you're using MP4, the X264 codec. This is the most popular one that people use today. So you probably don't need to change it. And then any kind of quality. That's if you're using FFmpeg. I would, if you're on a Linux machine, I would recommend using FFmpeg. If you're on a Mac, you can use FFmpeg and it'd be just fine. The thing is that OpenCV, which is popular, you can't create a video out of it. So it would create a JPEG sequence, and then you have to go through and put it into a video editing program, add the audio back in, sync it up, and all that other stuff, right? So, which is fine. I would use FFmpeg. And then you can always, if you just want to turn it into an animated GIF, like if you want to share a meme or something with something ridiculous in it, you can do that, and that's perfectly fine. And then you just hit convert, and this conversion into the video doesn't take long. It takes 2 to 3 minutes. All right, so most of your time is going to come in converting or training your model. That's what's going to take forever. All right. Okay, and that's it. So we got all that. Bam. So then we can close out of here when we're done. And
Sorry, just one quick
yeah,
question.
go for it.
So, did the model get like persist in some sort of format, like
Yes.
pickle or something like
Yeah,
that?
exactly. It did.
So, with that question, does that mean like there are pre-trained models out there? Online?
There probably are. See, what happens is that the model's trained for a specific kind of latent space, and so
Interesting. Okay.
they're going to be training for your face and then someone else's face. So that's what you're doing. But there probably are some pre-trained models between different people or different individuals if you want to try to do that. I haven't looked into transfer learning. There's a possibility that you could use some of those models and what they've done in the like on previous work, and then just add your own stuff in there, and it'll get pretty good at it.
So you could do it for cars, for example.
Cars?
Yeah, a Volkswagen Bug and a Porsche.
Oh yeah, so that's one use of GANs, is to be able to do like the art that you see, like that's how like the transfer art. So you can take any kind of picture and turn it into like Picasso style art or whatever. So GANs can do that.
I was
Absolutely.
thinking for movies.
Yeah,
You
sure.
can't find the Ferrari that you want, but you can use a Bug and then you just use this to put the Ferrari into the same.
Sure, absolutely. I think Hollywood's going to use a lot of these.
Thank you.
All right, so let's take a look at the final video and how it turned out. So,
Oh, that'd be an issue for actors.
yeah, we can talk about that in a second here, for sure. Hello, my name is Commander William T. Riker, Captain William T. Riker of the USS Titan now. And I'm here to tell you I've never met an alien who I haven't wanted to go to bed with. Even with my awesome Betazoid sugar mama, Deanna Troy on ship, I just can't get enough. Wait, what? Shut up, Wesley! Okay, so as you can see, if you take a look here, there's definitely some weak spots, right? William T. Riker, Captain William T. So you can see it's actually not too bad, but you can definitely tell that it's probably not Riker. But when the face rotates, it's generally okay.
Certain features. It's
Some of that could be managed by having the beard be more closer to Riker's beard.
Yeah, you notice that there was some audio, like the face, sometimes the words didn't sync, and I think it's because my lips were hidden by the mustache a little bit sometimes. So the system didn't pick that up as well. And then you actually noticed, yeah, see right there? You see how the head kind of moved out a little bit? So it didn't match as well there. So it definitely puffed out a little bit. So there probably wasn't enough images of Riker's face in that particular.
So how is it decided to use more of your beard than his beard? Because it's mostly focusing on light space, like the face?
Oh, I mean, that's what it seems to do. That's what it seemed to want to do here.
Okay.
So it probably did try to combine our beards a little bit, and that's why I chose something fairly close. Like our beards are fairly close. So, but this was the original source. Now what you do is if you switch the source materials, you can see that my face, when I was training, it did try to put my face on Riker's face, and then it used his beard with my face on it, but it didn't work as well.
I noticed that lighting works pretty well too. Is that
Yes.
like because you selected sources that particularly focus on the lighting, like giving it different shades of light?
Yeah, you definitely have to give it different shades of light. Now, if you want to use, the thing is the villain model, which is one of the options you can choose, which requires a lot more GPU power, is a little more susceptible to lighting challenges. So you definitely want to have on your source video or source picture, even lighting as much as possible. That'll definitely help.
If you were doing a face, like your face that has the beard, but you were trying to do a face that didn't have a beard, what would you expect the outcome to be?
I expect that there would be a couple of extra hairs here and there.
Just slightly?
Yeah, slightly. I don't think it would be too bad.
A couple extra for the hairless face.
Yeah. So I wanted for my first real full attempt at this to use something as similar as possible.
Sure.
But for our next attempt, yeah, I would, like if I was doing Jean-Luc Picard, I would definitely try that because he has no hair and I do. Like, how would that work? So I think that would be interesting. And so, you know, you talked about actually movies and doing these kind of things. It's funny because I'm actually, my next project with the deepfakes, I'm doing a trailer for a movie that hasn't existed yet. And just to play around with it, we've had some ideas. But it's going to get to the point where if someone made a very good deepfaker, they can make a lot of money right now. The actresses and actors are going to have to start licensing out their images. That's what's going to happen. Like, the question is, like, they did a James Dean one, which was really good. So who makes the money from James Dean? Is it his estate? Has it been too long for his estate to, like, make money from that? Like, how do you solve that problem? It's a good question. I don't know.
Well, you don't have to copyright something. It automatically is copyrighted by its existence. So that's the default.
Well, no, it's not about. I mean, the question
So
is.
where
Yeah.
I was heading with this is for actors and actresses, the default may be this is my image. It automatically belongs to me.
Yeah, but what if they're dead? Who does it belong to? And how long? Right? Because Disney's pushed that as far back as it could possibly go. Right? You know, Disney, the evil empire. So I think it's what 80 years now. But that means a lot of the original actors and actresses from before 1930 or so are probably available because they're in the common domain,
And
public domain.
And the royalties stop then too, correct?
Exactly. There's no royalties. Like, who do you pay for that? And so it's a good question. I think Steamboat Willie, one of the original animations for Disney, is now in the public domain because they can't fight it anymore. So that's a good question. Like, as we go forward, over the next 10 or 20 years, a lot of from the golden age of film are going to become available. Anyway, so that about wraps it up for creating deepfakes and going through the process. Thank you all for questions and going through that. I'd be happy to talk about it more. And yeah, that's about it. Any announcements? I'll just make them here real quick, which is that we are not going to have Lancaster AI next month, obviously because it's Christmas. But we are going to probably have trainings here starting in 2020 if you're on the mailing list. I know there's a lot of people on the mailing list. We will put that out. My guess is we're going to do trainings on stuff like PyTorch, TensorFlow, things that business uses of those particular things like fraud detection and stuff. We're going to take a look at all those options for people. So with that, thank you everybody. Have a happy Thanksgiving, and we'll talk to you soon.